Welcome everyone. My name is Rod Trewick and I'm a senior support engineer with DH2I. And today I'm going to demonstrate how to deploy a fully functional Microsoft SQL Server always-on availability group inside Kubernetes using Minikube and DH2I's DxOperator. We'll start by spinning up a single node Minikube cluster on Windows with Hyper-V, then deploy a single node SQL Server AG with one primary and two synchronous replicas managed entirely by DxOperator. So over the course of this demonstration, we'll be creating the Kubernetes cluster, applying the DxOperator YAML, and configuring the secrets. Also deploying the DX Enterprise SQL AG custom resource, exposing the environment with a listener and a load balancer, and finally, we'll test failover between the replicas and then clean up the cluster afterward. So yes, by the end of this session, you'll have a complete recipe for building and managing a production style SQL Server AG on Kubernetes, all from your local Windows workstation. So let's get started. So this demonstration assumes that you've gone through the process of installing Minikube. So the first thing that we'll do is we will start Minikube, and I'm just going to copy and paste my command in here. So you see we're using the Hyper-V driver. You can use the Docker driver, but our recommendation is for this demonstration to use the Hyper-V driver with roughly 8 gigs of memory. So we will execute that, and you can see it's creating the Hyper-V VM with the memory that we configured it for in this command. And it takes a minute for that to complete. And so we see this line here. It says done. kubectl is now configured to use Minikube cluster. So that's the message that you want to see. We will execute our kubectl get nodes command. Let's see if I can copy that in there. So we've got kubectl get nodes. We execute that, and we can see our single node here. Moving along to the next step, or the next stage here, we're going to deploy our SQL Server availability group using DxOperator. So we'll install DxOperator first. And to do that, we just execute this curl command here. And this will all be available in the guide that's published as a companion to this demonstration. So we will execute that, and you'll see that we have that v1cu2 YAML file downloaded into this folder here. And the next thing that we'll do is we will apply it. And so we've applied that YAML file now. You can see it's created. And the next thing that we're going to do is we're going to create a DX Enterprise SQL AG secrets. We're going to create the secret for DXE and for MS SQL, for DX Enterprise and for MS SQL. And what that looks like is this. So for DXE, the secret, or creating the secret, looks like this. And you will obviously want to put in your own password and license key here. And then this is what the command will look like for SQL Server. Obviously, you'll put in your own password here as well. So next, we're going to be applying the DX Enterprise SQL AG YAML. And I already have that here, and I can just cat that. So you can take a look at that. And this is what it looks like. And as I mentioned, this configuration will be published in an accompanying guide that goes along with this video. So you should have access to that to create and save where you would like, and then applying that. And there's an API reference that we'll link to in the document if you choose to make any modifications. So we'll go ahead and apply this. And we notice that that is created. And we'll give it a moment. And then we'll verify the status of our pods. So we might give this a couple of minutes to set up, and then we'll verify the state of the AG using our DxCLI console command. It looks as though we've got everything running here. So we can Control-C out of this, and we can execute our get AGS detail command. And as I mentioned, all these commands are going to be available in the companion guide. And so this gives us all the detail that we need to verify that everything is as it should be here. So we've got 3 synchronous commit nodes here. So next we'll create an availability group listener. So Kubernetes load balancers provide access to cluster resources via an externally accessible IP address. So we're going to define the load balancer configuration in a YAML, and Kubernetes will take care of load balancing incoming connections for us. So in the previous DX Enterprise SQL AG example, that contained a commented outline for the spec availability group listener port. We can uncomment out this line and then run kubectl apply again to update the custom resource with the new listener port. So here is our load balancer YAML. And I'll just save that really quickly here. And we save that as service.yaml. Make sure that it's there. As you can see, it's there. And I'll just cat that really quickly so we can see the contents of it. And execute our kubectl apply. And that resource is created. So next we're going to get the public IP address by executing our kubectl get service command. And so we can see here that our load balancer IP is 186 for this, for our DXE SQL AG0 load balancer. And it's still pending, so we'll have to give that a moment. In addition to that, we want to execute the Minikube tunnel command. So we'll do that from another PowerShell terminal here in another elevated session. So we type Minikube tunnel there. And once that's done, we should be able to do our get service command again. And we can see that our external IP address is now populated. Next, what we could do here is we could use the SQL CMD command, or SQL CMD command, to confirm that, or verify that we have connectivity. And that would look something like this here. Now, that does require that you have SQL CMD installed, and there should be a link in the documentation for that. And then, of course, you would use the load balancer IP here, the external IP address here, and then the password for the SA user, and the SQL password there, so that what you'd set up in the secrets. So the next thing that we'll do is our failover test. And that command, the command that we used for that, would look like this. And so that is the output from that command. So to demonstrate that failover, what we want to do next is, so we're going to delete the pod. So we're going to delete the DXE SQL AG0 pod. And once that's deleted, if we wait a few seconds for that to complete, then we can run our DXCLI get AGS detail command again and check the status of the databases. So notice that it's deleted, and we will execute our get AGS detail command again. And we see that it is back and synchronized with the availability group again. So again, after a few minutes, our deleted pod will automatically rejoin the cluster and synchronize with the availability group once again. So once that's done, we can set the role back to primary by running the following command. And give that a moment to complete. And the virtual host is started, and we can have another look here, and we notice that our secondary is now AG1 and our primary is back to DXE SQL AG0. So we effectively demoted SQL AG1 and brought DXE SQL AG0 back up as primary. So that concludes the demonstration of how to set up a Kubernetes cluster using Minikube, and then using our DxOperator to manage the cluster. So the last thing that I'll show you is how to clean everything up. So the first thing that we will do is we'll run kubectl delete and get rid of our DX Enterprise SQL AG YAML configuration. That's deleted. Then the next thing that we want to do is delete our PVC. And this should get rid of our persistent volumes. And you see that that is working on deleting everything there. And next, we will delete our v1cu2 custom resource, and that is deleted. And finally, we will delete Minikube, our Minikube configuration. And there you have it. So that is a relatively simple way to demonstrate or to spin up a Kubernetes cluster and use DxOperator to manage your SQL AG. Thank you very much.